I'd like to show you how to do a few things using Excel, including compare first and second order kinetics plots. So to do that, I've got a window with Excel here. You can see my mouse cursor. And before we apply this to some data, I'm going to generate the data. So let me show you how I would do that. First of all, I'll click on my first cell and say K equals, and I'm going to put in the value that I want to use for my rate constant. Let's say 0.0041. I'm just making up numbers. There, that's the rate constant I'm going to use. And I'm going to start with an initial concentration. Let's see, let's make this A0, whoops, 0. And I want that 0 to be a subscript. Let me show you how to do that. Up here in the formula bar, if I select the 0, hit Control 1, pops up the Format Cells window. You can also do that with a command on the top, and just hit subscript. That way it just looks right. Okay, and then I want that to be equal to, I don't know, let's say 0.200. And I want it to show 0.200, so I just click on this button a couple times to increase the number of zeros shown in Excel. And I see that my equal sign there got subscripted, so I don't want that. So let me fix that. There we go. All right. Now I'm going to make a column of data, one for time and one for A, concentration of A in molarity. And let's just center those. So I select that, hit the center button. And for time, let's say I want 10 different times spaced by 50 seconds. Let's see how that looks. So let's say equals sequence. This is a built-in Excel command that will build a sequence of numbers. Let's make it 10 rows long, one column wide, starting at 0 and with intervals of 50. Oops, something didn't work. Well, I do have to spell the command sequence correctly. There we go. That's what I want, sequence, okay? Help. Sequence. There we go. Okay, then it generates a list of 10 numbers. Here, I'm going to calculate my concentration using a first order equation. So concentration of A equals A0. I could click on this number, but let me show you another way of doing this. It's a little bit more convenient. So I hit an escape key to get out of that equals there. Let me go back up to my constants. And this, I'm up here in the name bar, I'm going to double click and enter K. I want that to be called K, so now I can reference that number by referencing K. Likewise, this number I'm going to call A_0 just to make it distinguishable from an address in Excel. Hit enter. And now down here in my formula, I want to say equals A_0 times exp of minus K. And you can see how it highlights K here. It knows what K is now, and it tells me what it's going to use. K times, use an asterisk for time, and let's call it time. And I haven't defined what T is, so this is going to give me an error. But that's all right. We can fix that. I'm going to call this variable here, I'm going to call it T. Now I only get one cell over here. There's a couple ways I can drag and drop this cell. I can grab the corner, that little green square here, click on my mouse and drag it all the way down, release, and it will copy, only copy that one formula because of course T is just the first cell. So I guess I have to do it a different way. I was wrong. So let's get rid of that. I make mistakes too. Easy enough to correct. Click on this. If I hit T and put a pound sign after the T, what that does is it tells Excel to use not only the value that I labeled T, but all of these additional spilled values that were created when I ran the sequence formula. So when I hit enter here, now it automatically generates those concentrations at these various times. Let's just make this look nice by centering it, and then maybe over here let's have a consistent number of significant figures so it looks decent. How about that? One more. There we go. Now, what I'd really like to see is a plot of this, so that's easy to do. Let me grab both columns, insert, make a plot, and let's make a smooth curve because this is just smooth data. So let me move my chart over here, stretch it out a little bit to make it bigger. That's what an exponential decay looks like if you just connect the dots and plot the curve. What I really want to do is generate data to give it students, for example, to see whether or not the data better fits a first order or a second order equation. So what I'm going to do now is I'm going to add some random numbers to these concentrations to give a little bit of simulation of experimental scatter. So let's do that. Over here, let's see, I want to multiply this number by a number that is 1 plus or minus a small random amount. So let me say this is equal to my original value times 1 plus, now in Excel a random number between 0 and 1 is given by the function rand, but I want a number between minus 0.5 and 0.5, so let me just put in a rand minus 0.5. What that does is it shifts my numbers that would be between 0 and 1 down to being between minus 0.5 and 0.5. And then let me just multiply that by some factor that will reduce the random scatter a little bit. Let's say, I don't know, how about 0.2? So what I'm really doing here, you can see in the formula bar, I'm taking my calculated value, I'm multiplying it by 1 times some small random percent that could be positive or negative to simulate some experimental scatter. And then I'm going to double click on this. Once my cursor turns to a plus there, double click your mouse button and it will copy that formula down the entire row. And let's see what that looks like. If I hit Control, hold Control down and then select my first column with the mouse. Now I've selected the first column and this third column. Oops. And I want to, oops, I should have selected data first. And add data. Let's see, let's call this randomized. For the X values, I want X. For the Y values, I want my randomized data. And OK. OK, and where's my data? How come it didn't show? Whoops. Series 1. Oh, there we go. I don't know what was going on there. I just decided. Now it's connecting the dots. I really don't want that. So I'm going to click on that and I'm going to say change series chart type. And the randomized one, I don't want scatter with smooth. I want just data points. So you can see that it's scattered a little bit around the data. All right, so now we have some randomized data. Suppose I take this and I copy it, Control C, and down below I'm going to paste it, but I'm going to be careful how I paste it. I want to paste it as values. So when I do that, if I click on one and you look up here, it's just a number, as opposed to up here, if I clicked on one, you see the formula. That way this doesn't update every time I do a calculation. It's just a number. So now I'm going to copy my time column, put that here. I'll label this as concentration of A. Again, center it. Now, suppose I'm given this data and I want to determine whether or not it's first or second order. I know, of course, that it's first order because I just made it that way. But suppose I didn't know. Well, I'd want to plot log of concentration of A. And I'd also want to plot 1 over the concentration of A. Okay, so let me calculate that. This is equals ln of, just click on the cell, close parentheses, hit enter. Here, this is equals. You always have to start a formula with equals in Excel. 1 divided by, click on the cell I want to divide by, hit enter. Select these two, go to my cursor makes a plus there and double click. Automatically calculated, and now I just plot this data. I'm going to make 2 separate plots here, one with the log data. So I select again using the control key so that I only select the columns that I want and not all columns in between. I insert chart type scatter. Let's move it down here so it looks like it's lined up. Let's stretch it out just a little bit. All right, I'm going to add a linear fit. The way you do that is right-click on any data point, select Add Trend Line. Over here under Trend Line, display equation on chart, display R squared on chart. I can go back here, select that, and move that box around to anywhere I like. Now, I really want to change how this is plotted, so let me go from minus 1.5 down to minus 3.5. So let's double-click on this axis. That brings up the Format Axis bar over here. Under the 3-bar option, click on that. See, it has a minimum of -4. I'm going to change that to minus 3.5. And I'm going to change the maximum to minus 1.5. And now notice it stretches out my data better so I can see it. It looks like minus 3.5 isn't quite enough. So let's go to -4 again. What the heck? I want all of the data on here. And I really don't like having the x-axis labels up here, so let's move those down. The way you do that is under the format axis with the y-axis selected. Go down here to horizontal axis crosses, and instead of automatic, click axis value. And the bottom is -4, so I'm going to enter -4. And now my labels are down here, the numbers. Then I want to add labels, so click on the plus here. Click on axis titles. It adds dummy axis titles to both sides, so triple click and type in what you want to call the axis. And then down here, triple click. And this is time in seconds. Whoops. Okay, and let's make a title. This is fit to first order kinetics. Okay, oops, there. There's our first order plot. Let's add a second order plot. So now I'm going to go back over here to data. I'm going to select the time. With the control key pressed, I select 1/A, and then I just repeat. Insert, chart, scatter. I'm going to move it down so it doesn't overlap with my other plot, but I'm going to stretch it out so it's about the same size. And maybe stretch it just a little bit this way. Once again, right-click on the data, add trend line, display equation, display R squared. Move it to somewhere where it's easily viewable, and then repeat the sort of steps. Let's see, it looks like my scale is pretty good. Scale here is pretty good. Let's add axis titles. So once again, I can click, there we go, time in seconds. Over here, triple click. This is 1/, concentration of A. And this time it's in units of molar to the -1. Notice the molar to the -1 doesn't look quite right because it's not superscripted, but you can select it with the mouse, hit Control-1 to get the font control, hit superscript, OK. There, now it looks superscripted. Change the chart title, fit to second order kinetics. I know, a lot of clicking. And that looks pretty decent. If you wanted to print this off, one way to do it is to select the cells that you want to print, including both charts. Under Page Layout, select Print Area, set Print Area. Now it's going to print only those cells that you selected. If you hit Control-P to print, you'll see a print preview, and it sort of cuts off the plots, but we can fix that. Change from portrait to landscape orientation. Make sure both plots fit. If they don't, you can always use scaling and say fit sheet on one page. That will scale everything, but it looks like everything's going to fit here. Now I print this off, and I've got all of my data. I've got both plots. I've got the linear equations. I've got the goodness of fit. And I'm going to hit Escape key to get out of Print Preview. And let me just emphasize, in this fit, oops, I didn't add my equations over here. Oh, that's the other plot. Sorry. Second order equation. R squared is 0.92. For the first order, it's 0.996. That's clearly a much better fit, and we've established that the data is first order kinetics.